Solving absolute value inequalities. Now, absolute value inequalities have two different forms once the absolute value expression is isolated. Let's look at our first form. These are going to be inequalities such as the absolute value of x is less than a, or the absolute value of x is less than or equal to a. So for example, the absolute value of 3x minus 2 is less than 5. So the pattern for those fitting this form, absolute value of x is less than a, is to rewrite in the form the opposite of a is less than x is less than a. So here we have no more absolute value symbols, and the expression is sandwiched or put in between two opposite values. So I could write, for our example, negative 5 is less than 3x minus 2 is less than 5. We took the part that was in the absolute value symbols, 3x minus 2, took away the absolute value bars. I still have the less than 5. And to the left, I take the opposite of 5, which is negative 5. Now, this is sometimes called a sandwiched inequality or a sandwich inequality. I think more officially it's called a tripartite inequality. And our goal here will be to get x by itself in the middle. So now we will solve for x by trying to get x by itself in the middle. So here, instead of just having two parts of an equation or an inequality to add, subtract, multiply, divide both sides by, now we have three parts. So if we're trying to get 3x by itself, let's start by adding 2, and I have to add 2 to all three places, to the left part, to the middle part, to the right part. When we add 2, we end up with negative 3 is less than 3x is less than 7. So x is almost by itself. Let's now divide everything by 3. So now in the middle I have x by itself. Negative 3 divided by 3 is negative 1. 7 divided by 3 is 7/3. And we get negative 1 is less than x is less than 7/3. So this is the solution written as an inequality. We can also write the solution as in interval notation. So what's the smallest value that x can be? Negative 1. What's the largest value? 7/3. Is negative 1 actually included? No. We have a less than symbol with no equal bar. So we put curved parentheses around the negative 1. Is the 7/3 included? No. Again, we have a less than symbol with no equal bar. So we have a curved parenthesis around the 7/3. So in green we have interval notation designating our solution. We can also graph our solution using a number line. So here I have a number line. You can draw in some reference numbers. The more important ones are going to be the endpoints that we have in our solution. So I want to indicate where negative 1 is, and I'm going to put an open circle there because there is no equal bar. So that means negative 1 is not included, and an open circle shows that negative 1 is not included. And then I'll put an open circle at 7/3 because, again, we don't have an equal bar. And x is in between those values, so we will shade in between these open circles. And so this is what our graph looks like. It has two open circles on the ends, and it's shaded in between. Let's look at our second form. Those will be the ones that once we get the absolute value expression isolated are of the form the absolute value of x is greater than a, or the absolute value of x is greater than or equal to a. So for example, the absolute value of negative 2x plus 1 is greater than or equal to 4. So the pattern for those absolute value inequalities in the form absolute value of x is greater than or equal to a is to remove the absolute value symbols and write as two separate inequalities. X is less than or equal to negative a, or opposite of a, or x is greater than or equal to a. So here we can rewrite our example as negative 2x plus 1 is less than or equal to negative 4, or negative 2x plus 1 is greater than or equal to 4. And the or is part of this. You need to write the or. It has a mathematical meaning here. So we took the expression that was in the absolute value bars, the negative 2x plus 1. It's on the left side in both of these cases. So it's greater than or equal to 4, and I have that right inequality showing me exactly that original one without the absolute value bars. And then the inequality I wrote on the left takes the opposite of 4, negative 4, and the inequality symbol was flipped. So now we want to solve both of these inequalities for x. So in the first one, we'll first subtract 1 from both sides, and we'll get negative 2x is less than or equal to negative 5. Now to get x by itself, we need to divide everything by negative 2. And on the left I have x, on the right I have positive 5/2. And because we divided by a negative number, our inequality symbol flips. And again, that was because we divided by negative 2. On the other inequality, we'll start also by subtracting 1 from both sides. And we get negative 2x is greater than or equal to 3. Divide both sides by negative 2. On the left I have x, on the right I have negative 3/2. And again, because we divided by a negative number, the inequality symbol flips. So here we have x is less than or equal to negative 3/2. Again, that was because we divided by a negative number. And we'll fill in with the or. So this is our solution, this whole expression written as an inequality. But we could also write our solution in interval notation. So what's the smallest number that x could be? Well, that would be from our left inequality. We could have go all the way down to negative infinity. And that inequality goes up to negative 3/2. Negative infinity is not an actual number, so it's not included. So we put a curved parenthesis. But negative 3/2 is included, and so we put a squared off bracket because we have that equal bar. It's less than or equal to negative 3/2. Or is represented with the union symbol. And then with the left inequality, the smallest number that x can be is 5/2. And x is greater than or equal to 5/2, so x goes up to infinity. 5/2 is included because of the equal bar in the inequality symbol, the greater than or equal to 5/2. But infinity is not included because it's not an actual number, so it gets curved parentheses. We can also graph this solution. So let's draw our number line. So we have x is greater than or equal to 5/2 because of the equal bar. We will have a solid circle or a closed-in circle around 5/2 and around negative 3/2. So here's my 5/2 closed circle. And I'm shading all the x values that are greater than or equal to that 5/2. So that's going to the right. Here's my closed circle for negative 3/2. And x is less than or equal to negative 3/2, so I'm shading all the values that are less than or equal to negative 3/2, which is to the left. And so here I have two different arrows pointing in opposite directions. And together, this is the graph of the solution to our inequality, to our absolute value inequality.